Good afternoon, this is Andy Schweitzer. We're going to do a couple sample problems on friction. Alright, so a couple things here. We have a box, weighs 5 kilograms, it's placed on top of a surface. Between the surface and the box there is a coefficient of friction that equals 0.3. So step by step I want to know, we're going to apply a force to this thing. Let's say apply a 50 Newton force to this box. And a few things I want to accomplish by this picture. One, I want to answer my question as far as this is, okay, if I apply a 50 Newton force to this box, what's going to be my overall question, okay, what is going to be my net force, or the sum of all my forces on the box when I'm done. Alright, so a few things. The first step I do, step number one, is I label my forces. Alright, so 5 kilogram box, we have our force of gravity going down. I have the resting force of force normal going up. Since I'm applying a directional force this way, I'm going to call this my force applied, and then the force of friction is the restraining force, or the force that's going to stop it, tend to stop it from moving. Alright, now once I have all my forces labeled out, I like to then break out into my components of my, wherever forces are acting. I have an X component and I have a Y component. So the X component will be in the horizontal direction, the Y component will be in sort of the vertical component. Now let's do the Y first. The Y component first. The box is not jumping off of the table or whatever surface it's on. It's merely resting and sliding from side to side. So the forces are balanced. With respect to the Y direction. So the force of the gravity equals the force normal, and therefore there is no net force in the Y direction. I will say, however, that the force of gravity equals mass times acceleration, and I'll do my calculations here. That would be 5 times 9.8 equals 49 newtons. So I have this, and therefore my force normal also equals 49 newtons. So I'll just sort of remark that's what we got. Now in the X direction, I don't know necessarily if the force of the 50 newtons would be enough to move the box, or if it's just balanced. Maybe it's traveling to the right at a constant velocity, so this exactly equals this. But I do know that the sum of all the forces in that direction are equal to the force applied, which is the 50 newtons, plus the negative force of friction. Now, the force of friction is equal to the coefficient of friction times the force normal. Now, let's just go ahead and calculate that. The force of friction is 0.3 as provided by the problem, and then the force normal is 49 newtons. So if you take 0.3 times 49 newtons, and 0.3 times 49 newtons is 14.7 newtons of frictional force. 14.7 newtons. Now, I am applying 50 newtons, so if I applied less than 14.7 newtons, then the box would not move. Right at 14.7, it would be equal. Equal force going forwards, equal force going backwards. So if, hypothetically, if I am traveling, I'm pushing the box at a constant velocity, okay, this would require 14.7 newtons of force. I'm not separating out the fact that we have a static friction versus a sliding friction. I'm just going with one friction in this case. They would be similar, but the static would be a bit larger. So So that would be a constant velocity or zero acceleration. Okay. Now, in this case, I am applying more than 50 newtons. So in the y direction, we will end up with a net acceleration in this direction. And that's going to be 50 newtons plus a negative 14.7 will give me my overall total acceleration in the horizontal component, and that is going to be 35.3 newtons. All right, so in this case, my net, now this is the, I should say, acceleration. The force will cause an acceleration, but we'll just call this net force in this direction now, which would be 35.3 newtons of force. And that could answer a question at this point if that was the question asked. Now, at this point, let's just answer the final question. We have some room here, I guess. Let's put it in the upper right, left-hand corner here. All right. What is the ending acceleration for this guy? Well, I have the force equals the mass times acceleration of the actual box, and this would be the net force applied to the box. Net force divided by the mass of the box equals the acceleration of the box. All right, and therefore I have 35.3 newtons divided by the mass of the box, which is 5 kilograms, and this will give me my net. Well, 35 times 5 is 7. Let's get the exact answer. 35.3 divided by 5 kilograms equals 7.06 meters per second. 7.06 meters per second squared. And that is how much our box will move with the friction force. This is your basic type of friction problem.